Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are working on module 2, the two projections of solids. In that projections of solids, we have completed triangular prism. Today, we will work on square prism with edge on HP, corner on HP, etc. Now, let me take a problem. A square prism of 40 mm base sides and axis 65 mm long rests with one of the base edges on HP such that the axis is inclined at 40 degree to HP. Normally it is 45, 30, etc. Not necessarily, it can be any random value suitably fixed. That means the total angle for a given entity like axis or diagonal diameter should not exceed 90 degree. That's how they give. Now I have taken 40 degree to HP. Draw the projections. Whenever you get a problem on solids, particularly the edge condition or corner condition, you get set of questions, different cases for the same data. Let me take first question. Up to this, okay, draw the projections. When the edge on HP is inclined at 45 degree to VP. Okay, base edge on HP is inclined at 40 degree. And then same data with axis inclined at 45 degree. Axis already inclined to HP by 40 degree. Again it is inclined at 45 degree. That is another question. Last question is the axis inclined 40 degree to HP and it appears to be inclined at 45 degree to VP. Let me discuss one by one. Now let me take the first one only and discuss at length. Let me take the model and discuss this problem. We have the square prism of certain dimension, say 40 mm base edge and height equal to 65 mm. Now when I keep this on HP, the solid must have either edge or corner on HP when it is inclined. Now I have edge on HP, one of the edge on HP. So I keep base edge perpendicular to VP. Whenever you keep an item on HP, if it is edge, it must be perpendicular to VP. Then only you can rotate. Suppose that I'll keep it like this at random. Then rotate. Then it becomes corner. So necessarily you must assume that there is a line perpendicular to it. I'll keep like this and then rotate. So this is how you must identify. Now axis inclined at some degree to HP. So what you should do is you should make it perpendicular to HP so that you get the true shape on HP. So once true shape is on HP, top view is true shape. So you start from top view. So let me draw first position of the problem. Now the top view is square with one base edge perpendicular to EP. So you know how to draw the square. Geometrically, what you do is you draw vertical line, draw perpendiculars and do it. So, or in computer you can easily, rectangle by 2 points is there, you can shift to the same size both sides and you get the problem. Now let me keep the top view properly. Okay. Now the naming should be done. First naming should be left extreme nearest corner. Then this is B, C, D. Then identify the axis. This is very much necessary for solids. Top center, base center. Okay, now get the projection up to the XY line because base is on HP initially. Project it and get the final position of base on XY line in initial condition. Height must be identified since he has given height as 65. Can take 65 mm height and mark. This is 65 mm. Okay. Now name these points. A1 dash, B1 dash, Assume that A1, B1, C1 is available. C1 dash, B1 dash, A dash, B dash, C dash, D dash, as usual. Then project this axis with the convention available. Okay. Till this point, it is regular. Then after that, axis point. This is O dash, O1 dash, imaginary line. Now dot this print you. Usually you forget the line which is on XY line. It is very important. Okay. Now as usual, dimension the print view, top view. Only the first figure must be dimensioned unless it is required. You see that the same position I have taken approximately. Don't go for offset. This is 40, 65. This is better way of presentation. Next, he says the axis is inclined at 40 degree to HP. So that's why we have taken axis perpendicular to HP and got the top view. Next, you try to rotate this solid. First position, second position. So you may ask me why not? This also edge, this also perpendicular. Why not you do? Yes, this is unusual. By default, you always take the movement in forward direction. First position, second position, third position or third position. Okay. Now, the requirement is the edge to be placed on HP is perpendicular to EP. We have done it. Now I rotate. So front view is a rectangle. This particular line is representing the rectangular face or lateral face containing the base edge on HP. This is inclined at 40 degree. The axis also assumes 40 degree. Instead of giving inclination to the HP, the axis, you take the reference rectangular surface and corresponding line is this. You give inclination to that. Manually, you can do this way, and computer, you move and rotate 30. It's easy. Now, you mark a point B1 dash, C1 dash. This distance must be little more than 1.5 times or 2 times than this. That's all. So that you can accommodate. Now, 40 degree to HP axis, and also this line, you can say geometrically if I talk. This line and this line are parallel. Definitely if I give to this line 40 degree, this also is same. So take 40 degree inclination and draw a line. Yes. Yeah. Now draw perpendicular using protractor. Manually if you are doing on sketchbook, and computer easy, move and rotate. Then take all these distances with compass and do it. Then draw perpendiculars. So should clearly understand how to redraw the figure. That is important here. So axis as usual. So identify this as, even though you have taken this as a reference, you take this. So HP inclination 40 degree with the axis. It's very clear. Name these points and then work out. Now this is A dash, B dash, C dash, D dash. Similarly A1 dash, B1 dash. This is already I have identified. B1 dash, C1 dash. Solve. So dot this portion. So whenever you get the opportunity to take this as the rough sketch, keep it right line, and then after you confirm, draw the dot lines in case of sketching. Otherwise, computer is easy. Now project all these points onto top view to get the second figure top view. That means we have given inclination to the solid with one of the base edge on HP, axis inclined some degree to HP, 40 degree. Now we have to get the corresponding top view in this position. In this position, now I have two colors, key surfaces I can say. One is base surface and top face. Top face is light color and this is dark color. If I keep it like this and rotate, as usual, lateral surfaces are white. In top view, you cannot see the dark color base. You can see only light. Why I am insisting on this? Majority of the time, we get wrong answers. Okay, this is visible, and vice versa. Now, you look at this, and I will rotate by 90 degree. Assume that this is top view. This is top face is visible, base is not visible. Okay, in this case. Now, first draw projections to get the top view. So, to get the top view, draw projections carefully. First, rightmost line and then bottom line. Unnecessary projections you can avoid. Then draw up to this. This becomes stoppers for you. Again, I am repeating many times. This is for top face and this is for base. Okay. Okay. Now, we name these points. This is A1, B1, C1, D1. Okay. This is A, B, C, D. Now, there are two methods of completing the top view or front view. Okay. Last session, I worked triangular prism and give an idea about farthest point which is not visible, etc., and then completed. Now, I will take up a typical method where you never commit mistake, but it needs the little imagination concept. That is what the reference is. Now, here this is top face, this is base. Now, I call this in future key surfaces, particularly prisms, key surfaces. Key surface, top face is key surface, another key surface is base. This is dark, this is light. Now, if you look from top, the top face is visible. This is the only criteria I need to complete the entire figure. I don't need anything. Just observe. I am looking from this direction, which is the nearest point to you. Is the observer position, which is the nearest point, nearest item, key surface, nearest key surface, top face, not the base. So, dark all the visible key surface. We have decided to have the top face as the key surface. Yes, it is fact, it's visible. Dark that first. Then I dark that portion. Okay. This is the basic requirement. Dark the visible key surface. Next, all boundary lines are visible. Second basic procedure is all boundary lines are, irrespective of the situation, all boundary lines are visible. Yes, this is the boundary of the top view. So, all boundary lines are visible. Yes, all boundary lines are visible. Next, invisible key surface. Next item is invisible key surface. Which is the invisible key surface here? Top face is visible, completely boundary lines are visible. This is invisible key surface, that is base. Now, let me take base into consideration. All four edges, according to the step reference, the base edges are not visible, but boundary lines completely visible. However, boundary lines is visible. So, here there are four sides, A1, B1, C1, D1, and this one is the only side which is not visible, because the lateral surfaces and this edge are coinciding. Number one. Number two, even in this case, base is not visible, but the edges are available and coinciding with this. In case of pyramids, for example, if I take up this pyramid, square pyramid, if I keep it like this, what is front view? Front view is a square, and midpoint is as vertex, and I have to draw in the slant edges as the dark lines. But even though base is not visible, this color, yellow color is not visible, base edges are visible. That's what referred to as, that is why I refer always boundary lines. Boundary lines are dark. So in this case, all boundary lines are dark. Then the only side which is not visible is B1C1, B1C1, that should be drawn dotted. So you can ask me why this procedure, why not only extreme edge? Extreme edge, the farthest edge, not extreme edge, farthest edge from the observer is B1C1, that is not visible, then rest of the items are visible. Yes, that is very fine, but that leads to confusion in some of the cases. That's why this particular procedure is to be followed. That's all. Okay, I hope this is understood for all of you. Next, axis reference. So axis, identify the axis, inline, then project from the previous top view for the equation. Yes, this is O1, this is O. So the particular reference is always important. Axis reference, okay, must do this way. So this is the axis reference. Now this is second position of the solid. I will repeat. First position of the solid is this, second position is this. Now I have the edge on HP perpendicular to VP, but I want this inclined to VP again, inclined to HP only. Now I want to have this edge on HP, the edge on HP perpendicular to VP. Now I want to give this way or this way. Normally we take by default base towards observer. First let me work base towards observer. In computer software I will show you alternate solutions. First position, second position, third position. How to do it manually? So here you have to redraw this figure such that B1C1 is inclined at 45 degree to VP. So in this case, observe, this is 40 mm, this is also 40 mm, no change in length because it is on HP inclined only, it will be true length. So true length on true inclination, you have to redraw this figure such that B1C1 is on 45 degree line. I will highlight this here. B1C1 is inclined at 45 degree to VP because I am referring actual base edge B1C1, capital letters. Now I can say B1C1 of second figure top view. Second figure top view is inclined at 45 degree to XY. So TL on TI. True length on true inclination. True inclination is 45 degree. Now I have to redraw it. That's all. Now how to redraw? So better you take this 45 degree like this and then place entire thing on this reference. This is 45 degree. You can ask me, why not you take in this way? Yes, definitely you can take. It's not a problem. Alternate solution I will give. Now what I do is I will take up this same figure. I will take here. You know how to redraw it using geometrical references. You can do it. Okay. Assume that I am using the protractor. There are many instruments. I will show you the set squares, mini drafters, not mini drafters. You have the rotoscale here. You have rotoscale. You can do this and move this way and draw lines. And also perpendicularly you can keep. You can use perpendicular projections. set squares. All these things you can use and then draw. Here, assume that I have used all this and then redrawn this figure. Yeah. Okay. Now, yes. Okay. Assume that I have redrawn this is that B1 C1 is on 45-degree line. That is true length and true inclination. So keep all the namings properly. This is D1, this is A1, B1 C1, A, B, C, D. And axis, all these things you have to identify. O1, O. Next, you have to get the projection. Now, the position of the solid, first position, second position, third position. Now you can see dark color key surface is visible to you. First position, second position, third position. If I do like this, if I take base away from the observer or nearer to EP, you cannot see the base. You can see only top face. Now, first position, second position, third position. Purposefully, I have taken like this. By default, you also do that unless it is demanded for a particular key surface. Then project this upwards. First, let me complete base, then top face. That is better way of working. Don't keep all the lines while working manually, and even computer, keep one by one. I will show you how to do it on computer. Now, right now, I keep the base sides projected onto the front view. Okay, you know very well that B1 C1 on ground are HP. B1 dash C1 dash. Wrong naming leads to wrong answer. Take care. Now, this is to be projected for the base corners A and D. This is base corner, take care. This is D and this is B. BC is over, then A. Now, A, B, C, D I have projected and got the corresponding points. This is B1 dash, this is A1 dash. Join them. Light lines, use light lines and join them. Keep it ready. So, next comes the projection from the top face. So, as usual, this is the first line refers to BC. Project one by one. Don't be in a hurry. Leads to wrong answers. This is B and this one is C. Sometimes single line works for both, but you may have to be must be very careful. Side by side you get very close. Next comes D and A, the topmost point, right? D and A. Yes. A dash, then this is A dash, this is D dash, this one is B dash. Yes. A, B, C, D. Join them in order, like lines. Next comes the line joining their top views and corners of the front view already of top face and base you already obtained. So, DD1, CC1, A1, BB1. Normally on computer you get proper way of working. That is parallel line you get. Even luckily I got parallel lines, all are intact. Now, how to complete this? Again, I will use second method, that is key surface method, visibility of key surface, and then complete the boundary, not the farthest point. I will again explain that using farthest point also. That is most easier, but you should not get confused. But this is systematically you have to do. Now I am here. So as usual, first position, second position, third position. Which is nearer to you, key surface, base or top face? Both, base. That's the only criteria I need. I don't need anything to complete the front view. I need not have to refer any line in the top view. How? It's possible. Now, first draw the visible key surface. Visible key surface is the base. Observe carefully, it is very interesting. You never commit mistake using this method. Visible key surface, even though it is not visible in top view, it is visible in front view because of this reason. I have taken first position, second position, third position. Dark surface, key surface, base is visible. Okay, top face is not visible. So, immediately after we complete the base visible key surface, you draw the boundary lines. Okay, dark boundary lines. All the time, irrespective of the situation, boundary lines completely dark. All boundary lines. Boundary means edges of the solid, not any construction line. We take care. All boundary lines are visible. This is step 2, basic step 2. Basic step 1 is visible key surface dark. That is, base is visible since it is nearer, base is visible. Then boundary line is dark. Then invisible key surface you take. All invisible key surface lines are dotted, that is invisible, but boundary lines always dark. You must have that condition in mind. Even in farthest point method or item method, we have taken that also. These two lines, C dash D dash, C dash B dash are dotted lines. So let me draw dotted lines or invisible lines for this. Okay. So I have completed 3 basic procedure. One is visible key surface. Since I have 2 key surfaces in prism, in case of pyramid we have only one. I will tell you what to do. Easier. We have 2 key surface. Visible key surface dark, all edges. Then boundary lines dark. Then invisible key surfaces other than boundary lines are not visible. Boundary lines always visible, that we have fixed. Now, how to complete the CC1, DD1? Only 2 have left. How to do it? So one may say it is nearer, it is visible, that and all. No. Then I will tell you the basic, very basic fundamental concept. See, here I have visible key surface. And in this case, you can see this longer edge, this longer edge. You cannot see this longer edge. Why? It is behind this surface. That means visible, I will keep this, visible surface, invisible line. It is always true. See, this is visible surface. Any lines passing through that visible surface, they are not visible. Okay. Suppose that you are in a city where we have the railway track, above that we have roadways. Okay. If you are in railway track, you cannot see the person or the vehicle which is just below, and vice versa. That is, I always refer this as crossing line. Crossing line. If any line crossing the visible line, this becomes dotted. Okay, if it is already dark, this becomes dotted. Crossing lines always opposite in nature. Okay, have that in mind. So it is fact. It is not a thumb rule or some different method. It is fact. Our basic concept is visible surface, invisible line. So what I do is, according to crossing lines, invisible surface, visible surface, invisible line. So I draw dotted line. It's very easy. Visible surface, invisible line or crossing line. There is one more very interesting. Okay, I will tell you next. Let me not confuse you. This is crossing line or visible surface, visible line, invisible line. Next, what about this line? Again, same thing. I have dotted line. I have one more edge passing through that. Definitely, it cannot be dotted. It should be dark because crossing line. Otherwise, invisible surface, visible line. See, in this case, I will keep it like this. Top face is not visible. Top face is not visible, but this edge is visible. Okay, that's how we can analyze. Or crossing line. Crossing line is, sorry, this is dark because this line or edge is crossing the dotted line. Now, I will try to review this again by one more interesting information for you. I will redraw. Yes, draw these lines. Assume that thin line is available. Thin line. I have to make it whether it's dotted or dot. Now you know this symbol. Let me have one more additional symbol for me. This is Benz. Benz car symbol. Inside the boundary, any corner you take, it will follow this particular pattern. In future, for any explanation, I refer it as Benz. Already two lines are dot. One more line joining that line also, that point also dot. So see that this particular line is dot. This particular line is dot. Why this particular line is dot? Because it is Benz. That's all. Reason you can do very easily. Or invisible surface, visible line. That's all. If you come to this point, I can say it is Benz. Here you can see again. Now this is dotted, this is dotted. According to this symbol, I have again this particular line should be dotted. Why? It is just because of Benz. Very simple. This is how we can complete. Basic, I will repeat, basic concept is visible key surface or invisible key surface. So, visible key surface in this case is base, I have darkened the base. Fine. Next basic procedure is all boundary lines are dot. Fine. Next, invisible key surface edges other than boundary lines are dotted. Yeah, I have two lines which are uncovered by the boundary line. Yes. Now, how to complete? Either through crossing line or Benz or basic reference, visible surface, invisible line, invisible surface, visible line. This is always true. Okay, this is fundamental concept. Okay, now this is how we can complete the top view or front view. Next, let me take up same thing, same problem and discuss with the farthest point method. Now already completed, I will justify how exactly. You can also do that. Now which is, see I am here, which is the farthest item from you? This point. C. C is the farthest item from you. According to the concept, the item which is farthest from you is not visible. Yes, C is not. Any number of lines connecting to that are not visible. Okay, that's how we have taken these three lines dotted. The rest of the lines completely dot. Very simple. Now, if I come to this point, yes, if I come to this point, I am looking from this direction. The farthest item from me is B1, C1. That is not visible. And according to the concept, any number of lines connecting to that are not visible. But it is not so. Boundary lines completely dot. That's how it is taken care by the boundary. The reason being, see, in this case, the lateral surface are coinciding with the base edges in top view. That's why you never get number of lines. Once it is rotated, then only you will get that item in pentagon, etc. Number of lines you get, then we can discuss at length. Now, this is how you can complete top view, front view of a particular problem. Okay, so whichever is you feel better, you can adopt that particular method. This particular item is very easy. Invisible surface, visible surface, etc. Can do it. Anyway, I will show you on computer software how exactly it works well for you. Now, second item is axis inclined at 45 degree to VP. See here, it's very easy for me to interpret the same solution. See, axis inclined at 45 degree to axis inclined 45 degree to VP. So what you have to do? Axis inclined to both the planes now. So once O1, the case 2, I will discuss case 2, axis inclined to both planes, both HP and VP. Now, O1 is apparent length. This is 65, this is less than 65. So naturally, you have to keep it on apparent inclination. So we have done that last time. So AL on AI. So you have to find apparent angle. How to find apparent angle? You take the true length of the line. Separately you can do. What is the angle of inclination? 45 degree. Okay. Then take this O1 of true length. True length and true inclination. Always true length is associated with true inclination. Next, take apparent length on this locus. Draw. This is O1 of apparent length. O1 of apparent length. This angle gives you definitely the beta value. So in this case, you get around 67 degrees. I will show in computer software. This is, you have to redraw this figure such that it's not on base edge. I am not considering. I am considering the axis. You keep this axis on O1 beta degree line. Sorry, this is beta degree. This is 45. This is 5. This is beta. On this line, you have to redraw it and project. Same type of the procedure you have to do. What about last one? Axis appears to be inclined at 45 degree. Now, you just observe the geometry. The base edge is inclined 45 degree means what about the axis? According to geometry, this is 45 degree. So, answer is this only. Within no time, you will get the answer. This is beta equal to 45 degree. That's all. Same solution. Now, case 3, I can say case 3, okay, beta is given. That's all. So, what you have to do is O1 is on beta degree line. That's all. Nothing else. Same solution is the answer. Now, I will do it separately in the computer software. So, this is how you will get the questions on the solids only inclined to HP with respect to the axis. Then you get the other items like base edge on HP or the axis itself is inclined some degree to VP. I will show it on computer software. Let me take the question which I have discussed already. A square prism 40 mm base sides and the axis 65 mm long rests with its one of the base edges on HP, so that axis being inclined at 40 degree to HP. Draw the projections. The edge on HP is inclined at 45. This is the case 1, this is case 2 and case 3. Now, whenever you get a problem on solids, you must have two things in mind before drawing initial condition. First, you must observe axis condition. So, normally in syllabus itself they have mentioned the inclination of the axis with respect to HP only, as the solid itself. Reference can be different. The overall axis inclined at 40 some degree to HP, that's all. The axis is inclined at 40 degree to HP, so make it perpendicular to HP to get the true shape of the cross section on HP, so that the top view will be true shape and start from top view. So that's how we started the work from top view. Fine. This is the top view and corresponding front view as I discussed. Okay, that I have shown you in the first problem how you exact. Then whether it is corner on ground or edge on ground. Yeah, basically it is base edge on HP. One of the base edge on HP. The edge to be placed on HP is always perpendicular to VP, provided the axis must have inclination to HP. Okay, now that is in first position. So that is what we got it. Now this is how you draw the square and then dimension it properly, and then height you take and then fix all the points in accordance with the requirement. So this is the left extreme nearest corner, start from there and visible point B, C, D, correspondingly we have all these. Next, what you have to do? You have to move and rotate for giving inclination to the axis. So axis inclined at 40 degree to HP, it is very clear here, 40 degree to HP. See, the axis being inclined 40 degree to HP. to this particular item. Yes. Now what to do? So you move and rotate. So how exactly you move, that I will show you again how to move and rotate, so that you will get clear idea. Show you one of the problem so that you can get the idea. Okay. Now I will move. See here you must have the dark portion. Yes. And you see that whenever you move, you can have a reference. Otherwise, it leads to a lot of confusion. See, for example, you are moving from, don't move at random. You take this, one of the base point as a reference, and so that you get the point on the XY line. Symbol is this. Then you are pakka. You have made that point, this entire thing rests on XY line only. So, B1, C1 will be an XY line. Suppose that you take at random, it may be somewhere, it may be very close, not exactly that. Now you rotate. How to do it, I will tell you. What is the inclination? You check carefully. 40 degree to HP. The axis inclined 40 degree HP means this particular line also inclined 45 degree to HP. I will give inclination to this. Definitely it assumes. Otherwise, you can convert that into base and do it. No problem. Now totally at the end you check the angle you have taken. Now I will rotate the particular item which is available here. Now you see that this is blank. Now rotate about this B1 C1, I must keep it on HP. That's why I have taken this as a reference. Then take this, rotate. Since it is 40, you must be very careful. With respect to vertical, you must take 50, so that you will get 40 with respect to XY. So normally the people commit mistake by taking this as 40. So see that this is playing, then see. Now you check for the axis. So axis inclination must be identified. So I have given for this, naturally I will get the difference. See, this is 40, pakka. Yeah. So now the position is ready to get the top view. So you know how to draw the top view. That's what I have done. See, this particular line is, as I explained earlier, this particular line is referred to as lateral surface containing the base edge on HP. That is also inclined, but that only I have taken to give inclination to HP for the axis. So I have identified. Now once you project it, you will get the stoppers should not exceed this. Then project all these points here. Now name it, all the points. So carefully in order A, B, C, D, E, F, G, H. Then you will get this position. Now I use this method. Farthest point method, you know how to do it. Here I have given the clear idea. Check for the key surface. The top face or base, dark all the edges of the visible key surface. If no visible key surface, don't go to the next step. That is case of a pyramid. Now dark all boundary lines. Second step is work. See what I have done. So after getting this thing, if I look from this direction, top face is nearer to me. So I have to dark the top face. Then dark all boundary lines. Second basic procedure. Third basic procedure is check for the invisible key surface. Yes, this is invisible key surface A1, B1, C1, D1. Out of 4, 3 are covered by the boundary line. Only 1 is left. That should be dotted. Okay. Suppose 2 are not covered by the boundary line, all the 2 are invisible. So that again depends on the shape of the side and also position. Now we will look for such situations. Now what I do is I will keep the first invisible key surface dark. I have made it little change in color. Visible key surface dark, and then boundary lines dark I have to do. Next, see, I have done boundary lines. Still C1, B1 is pending. What to do? The invisible key surface edges other than boundary lines are dotted. So I make it this dotted. Okay, yes, made it dotted. Now unlike the different problems, I don't have any other line to use, crossing line or bends or invisible surface visible line and invisible surface visible line. Here the thing is I have completed, axis also you complete. Now I have to see that the edge B1 C1 which is on HP is inclined at 45 degree to XY line, or VP I can refer. Capital B1 C1 is inclined at 45 degree. At the same time I can address the top view line B1 C1 with respect to XY, okay, because that is one projection. Now give inclination and first move and rotate. Okay, so you know how to move. I have shown you a number of times. You move to a particular position and then rotate. You need not draw 45-degree line, then see that that is on that. No, you can just directly take. Okay, I will show you how to do it. Now you rotate this, take the rotate command, and then take B1 as reference, and then take this. Since 45, it's very easy for you. No question of this one. Okay, yeah, that's all. You check. I have not taken any line with 45-degree reference earlier. Now we check. Yes, it's easy. Now this is how you can do that job. Okay. Now you see, this is how you do it. Next, as per the key surface concept, which is the nearest key surface to you? Yes, base. Base is visible in front view. That's all. That's the only criteria I need to complete the solid projections in front view. So you are looking from this direction. Okay. Now you are looking from this direction. So first you complete all the basic thing. The base things should be projected. All corners you have got, and then top face. Then you got this. Draw this one. This is how systematically you can do on computer. Then join all the four corners. Now you can check. I am here. Which is the nearest to you? Base. So base is visible. Assume that this is red, this is green. This is green, this is red. Which is visible? Red. So here I can use. You can also do this job whenever you are free to do it. You can use this shading. Okay, and then see. This is the visible key surface. In this case, which is the key surface here? Visible key surface, base. I can do that job here because it takes the just for understanding purpose. Yes, this is the visible key surface. This is not visible, and as I told you earlier, it is a visible key surface, invisible line. So invisible surface, visible line. That also you can adapt using this. Okay. Now, after this, boundary line is completely dark. Basic three procedures you have to follow. Visible key surface adjust dark, boundary lines completely dark, then invisible key surface adjust other than boundary lines. These two are boundary lines, these two are dotted. Okay, so let us see how it works. Now let me again tell you the whatever I have given you. The visible key surface, invisible line, invisible surface, visible line. This is crossing line again, and this is invisible bend, this is visible bend. That's very interesting. First you complete three basic procedure, then we can use this or check through the fundamental concept. Now see, this one is visible key surface dark, then comes the boundary lines completely dark. I have made it dark. Then see that the invisible key surface edges other than boundary lines dotted. Then these two lines you have to complete. This is invisible surface, visible line, or crossing line, opposite in nature. Or if you come to this point, it is bends. This is dark, this is dark, this is also dark. Then you come to this point, this line, very interesting. CC1, it is actually dotted because bends. This is dotted, this is dotted, this is also dotted, invisible bends. Or crossing line. Already dark line is there, you cannot have another dark line. Or fundamental concept, this is visible surface. Okay, so I can explain this. See, this is visible key surface. You cannot have again dark. But some people may say, why do you complete up to this? You stop at here. No, it is edge which is completely available but not visible. So entire CC1 is dotted because visible surface, invisible line. Okay. Now I can complete this line as dark, this line as dotted. This is dark because of bends, visible bends, and this is dotted because of invisible bends. Or I can say crossing line. This is dotted because of crossing line. This is dark, this must be dotted. Again, this is dotted, that's why this is dark. Or, I repeat, visible surface, invisible line, invisible surface, visible line. Say, don't get confused much. It is very simple to understand. So I have completed same thing. It is on this. What about this one? This is dotted. Now see that this is okay, completed. Now axis. You must always see that axis must be completed. See that this is maintained 45 degree. This is the complete solution. This is the final solution. Whatever I have done so far for you, it is the complete solution for the first case. Edge on HP is inclined at 45 degree to VP. See, edge B1, C1 is inclined at 45 degree to VP. Axis inclined at 45 degree to 40 degree to HP. That's all. So I will repeat. Surface towards you is visible. Here is the observer. And boundary lines are dark. The invisible key surface edges other than boundary lines are dotted. Then how to complete remaining two lines? You start with crossing line, check with bends. Or fundamental concept, invisible surface, visible line. Then we come to this point, start with bends, check with crossing line, or visible surface, invisible line. Very interesting. And you can also check with your farthest point. See, farthest point is top corner C. C is not visible. Any number of lines connecting to that are not visible. Here, boundary lines are not coming in the way. No confusion. It is very crystal clear. You have exactly separate lines. None of the lines are in the boundary line. These three lines are dotted. That because this corner is not visible, any number of edges, longer edge or smaller edge connecting to that are not visible. All the rest of the lines are visible. So that is simple. But sometimes people get confused. That's why you can either use this method, keep surface method, or the farthest item method. Now assume that the base is towards VP and top is towards observer. What happens? Now I keep the base, same problem, alternate solution. The thing is, I have the base towards VP and top face towards observer. What do you say? Top face is visible. Okay, because top face is nearer to the observer. Same thing, I have completed. They see top face is visible, boundary line is completely dark, and then the base is not visible. The out of four edges of the base which are not visible, two already covered by the boundary line because common to lateral surface and that base. That's why they are visible. Now remaining two are not visible. Then what about these remaining two lines? Because this is invisible bends, crossing line, or visible surface, invisible line. Here if you come to this, you can justify this visible bends or crossing line, then one more invisible surface, visible line. Okay, again the as I told you earlier, the farthest point concept, D1 of the base is the farthest point item from you. Here, you are here, farthest item is D1. Now that is not visible. Any number of lines connecting to that are not visible. These three lines D1 dash, D dash, D1 dash, A1 dash, D1 dash, this C1 dash are connecting to that. They are not visible. Rest of the edges completely dark. Yes, we have done it. Now this is how you complete the problem on the square prism with the base edge inclined at 45 degree. Either the top face nearer to you or base nearer to you, as I explained in this case, this one or this one. Next, second case, case 2. See, case 2, what I have done? Axis being inclined 40 degree to HP and 45 degree to VP. When axis inclined to both inclined to both the planes, OO1, just observe here, OO1 of the solid in second figure top view is apparent length. So apparent length on apparent inclination, AL on AI. So find beta. So to find beta, you know the procedure. Take true length of the line, on true length always associated true inclination, you draw the line, then draw horizontal locus. This is the concept of straight lines. Then take the apparent length and then draw an arc, you will get beta as 60. You take this procedure in this area, and then if you get confused or any problem is there, you can do it separately by the side. and take a separate sheet and mention there to find beta, you use the particular sheet if space is not available, then directly take this and the 67 degrees. Okay, sometimes it leads to confusion, and also some rotation also leads to some irregularities here. So better you take separately and do it. So again I have taken base towards observer, same concept I have explained here. Base is visible, yes. Boundary lines dark, top face edges is other than boundary lines are not visible, and this is bends or crossing line concept, yes. Otherwise farthest point. Now case 3, axis being inclined 40 degree to HP and appears to be inclined at 45 degree to VP. So definitely this is very interesting. Directly you can take this 45 or this same first problem itself is the solution, because instead of this 45, see this 45 you can dimension this because of geometry. This is 45, this is also 40, because these two are mutually perpendicular. You can directly take, only changes this, you can do that job. See, appears to be inclined at 45 degree to VP. See here, this is the same thing, appears to be inclined, so you know how to do it, that you can do easily. Same procedure, no change. Now I use the same thing with respect to the farthest item concept. I have done that job, very easy, check. See, farthest item, you know, first two figures are same for the case 1. This one is the only which is not visible, but lines connecting to that are this one and this to this item, but all are boundary lines, so they are all visible. Only this one is not visible, base edges, because away from the observer, rest of the things are available. So this is how you can complete. Now the thing is how to redraw the figure, that also you know. I am taking this. Now farthest item from you is C, and these 3 are not visible, rest of the things are available. Now complete position. So this is how we can complete the problem on square pyramid with the 3 different cases. We will discuss in detail the different shapes, pentagon and also pyramids in the coming sessions.